Welcome everyone to the Minimalist Dev Room for the second time we're organizing this. And so far we've had some great talks. I hope I can live up to that expectation. So, Lisp is the second oldest language in use today. The oldest language is Fortran. And I just yesterday there was a Fortran to LLVM talk, so that's also still alive. Fourth, we also had a talk, which is quite old. It's early 70s, I think. Yeah. Smalltalk is also quite old, so these old languages seem to stick somehow, which is great. So yeah, I've went through many phases in my life. I've started programming in the early 80s and went through from Pascal through C++ to Python, Ruby, whatever, Elixir, Scala, D, and I still like Ruby and I still like D. So, what about Lisp? So one of the things I learned is that the top 2% of the programmers in the world they can program in Lisp. Have you heard about that statistic? So of course, when you want to be a top 2% programmer, what do you have to do? You have to learn Lisp. So that was an incentive. And then I ran into a number of projects, including GNU Geeks, which is a package manager written in Lisp. And so slowly I started to, and it's surprisingly easy to learn. You can teach a youngster Lisp probably in an hour, I think. Yeah, the basics. So that's great. But I also discovered that Lisp is very much a Ruby, or a Ruby is a Lisp, really. And I met Mats, who's the creator of Ruby, 2 years ago, and I asked him, how come Ruby is so much like Lisp? And he says, yeah, actually, people in the early days called it Max own Lisp instead of Ruby. Yeah, so there's a lot shared, and so also Lisp is a lot like Python, or Python is a lot like Lisp, and you find these things out. But there's something else. Lisp is everywhere, and I'm going to talk about that. So Lisp you can find in Emacs. You can find in the education, great programs. AutoCAD in the early days used Lisp. GIMP, Julia was originally written in Lisp. You know that? So they're Lispers there. Logic programming, Minikanran. Clojure in the last 10 years has wedged itself into the business market. GNU Geeks, of course, is very much popularizing Lisp and pushing Guile to its limits, and that's the next talk. Then we have GNU Mess, Jan was talking about just now. Yeah, there's a lot of Lisp in there. And the shell, anyone heard of shells, Lisp? There we go. So, in a nutshell, most programming language writes and then braces and then a parameter. In Lisp, the braces are just on the outside. That's all you need to know. So when people say there's lots of parentheses in Lisp, meh. And where most languages handle scope with curly braces in the C-style syntax. And you have imperative assignments, right? And then you do something like concatenation. In Lisp, you write something very similar. It just looks a little bit different, So you start with a brace, and then you assign the parameters, right? And then you do something with it. But what you can see is that it's very consistent, because functions are always start at the first position in the brace, so that's how they get evaluated. And then you get a list of parameters. And even for assignment, it's really a function, which has a list. So, and the other thing is that most lists today, they allow you to also use square brackets, right? So as long as they match up, you can exchange them with the braces. But interestingly, it introduces scope. And one of the things I found out quite late, which is embarrassing, is that, and this is really beats other languages, I think to the core, is when you run Lisp in a REPL, so you can just cut and paste the inside of an expression, right, and feed it to the REPL again. So if you do debugging, try that in Python. So here's a famous Lisp. It's running in an editor. And here's an example. Yeah, so Emacs is written in Lisp, essentially. It has a very small C core that runs the Lisp engine, which means that all the configuration is done in Lisp too. Yeah, so once you get used to the Lisp syntax, you don't have to relearn anything. What you only need to relearn is how, Emacs has created its world of functions or procedures, which you just can call. Yeah, so I wrote a function at some point that I wanted to copy the line above, and I probably did it in the most inelegant way. Yeah, because I wasn't really into Lisp then. But you can essentially write a function that says, take the cursor position, copy the line above, inject it back into the text buffer. You can even inject it into a different buffer if you want. And this is what it looks like, and it starts to look familiar now. And then when you have written the function, you can bind it to a key, right? And in this case, it's Control backspace. And let's see if it works. Yeah, right? So I wrote this language extension myself. It's a really minor one. But I think it just shows the power of using a configuration language, which is also a programming language. So Emacs is for programmers. So that point I really would like to emphasize. In fact, I used Vim for almost 10 years. I started with Emacs, then in a mind melt, I went to VI, and then 10 years later, I went back to Emacs. And the real thing is that because this is such a configurable editor, it becomes a great programming platform too. Yeah, so programmers love an editor that you can program. And that's what Emacs is. Racket. So this is another Lisp, which is really making Lisp popular again. And the Racket has comes with a shell. It's called Rash. Yeah, so it's an unfortunate name, but there you go. And I just want to run quickly through it because Racket allows you to mix shell commands with Lisp commands, which becomes very interesting. So you can install Racket. I'll share the slides. And then you can say something like require some modules, right? And then, hey, that's a shell command. See that? Cat, etc. hostname. And you can pipe it into a Lisp procedure. And that pipes it into another one. So what you can do is say, trim a string. Or you can say, let's see, here's the mixture again. Define hostname is cat, etc. So that you have the embedded shell again, right? And do some function operation on it. And then you can just run a plain shell script, yeah, where the parameter is actually lifted out of the Lisp evaluator, right? And that's already pretty cool. But you can also do things you can't even fathom doing in a shell, like parsing JSON. Right, so this is a REST endpoint, which returns a very complicated JSON record, and I can just fetch it within the shell using a Lisp expression, and the record in the first stage of the record is a hash, is a dictionary.
Don't worry, we're trying to think of.
What are you trying? Hey, Alistair. How are you? All right. Is it not the blue one, the black one? Yeah, try. Ready for liftoff? Yeah, so you can do something very complicated, and then if out of this JSON record you get this string. So in a shell script, essentially you can do complicated things, and you can even do you can use SQLite as a backend and push some state into a SQLite file database. Try and do that in a shell. Another thing is the shell scripting program where, and probably most of us get caught at this at some point. The shell, when you pass a list of words in there, is it a string or is it a list? Yeah, so here's an example. Here's the shell script that I used to upload some files to my web server, to my mail server. Yeah, and you can see that the file name has spaces in it. Okay, and when I actually run this script, which simply is shell and then using the expansion string star, of course it breaks because it thinks these are all different files, right? Anyone bitten by that before? Yeah, so the rash version is that you start the shell, and you can parse the command line using current command line arguments, and you can see if you use single quotes, it actually sees it as words, but if you use double quotes, it will see it as a string, as something with spaces. So to write the full script, you could do something like this, where you say, okay, we're going to run a system command, the system star calls the rsync and plugs in the fn, which is coming from current command line arguments. So this is a lambda, and in lambda the actual parameters to the call are listed last, which is counterintuitive for us Ruby programmers. Yeah, so you turn but Racket comes with a nice facility where you can say for list function name, that's the parameter, fetch it from the command line, and then run the command. And this starts to pretty much look like Ruby to me. Yeah, I mean with a little bit of syntax. And then you run it, it works, right? As it should. Skip this. So here's a more full rash script where I just show that you can create a loop. Yeah, so the student file lists student names with spaces, and then I create a name removing the spaces, and then I copy the file, a text file to the output file, and then I run sed. Hey, and this is again just a shell command essentially. Yeah, and this is also a shell command. So what you see is you can mix in a loop. You can mix shell commands again, which have the normal shell syntax. So I think Rush is pretty cool, and for Guile we have Gash. If it could do this type of thing, Jan, really interesting. So there's more reading here. You can read on Racket. And why is Rash so interesting? Because Rash is totally hackable through Lisp. So you learn one syntax and you apply it for different things. Need to go out of the time. So there's some hacking guides here. This seems to be misplaced somehow. Whoa. What did I do? GNU Guile. I'm starting with the hacking guides. Great. That should be the last one. So GNU Geeks, you've heard of before if you were in the room, is a package manager. It's a functional package manager, and it's essentially written in Guile, which is a Lisp again. Yeah, there are many flavors of Lisp, and this is one. It's a scheme. And when you install something with Geeks on the command line, you can do something like Geeks package install Racket Emacs Racket mode, and then I'm going to put it somewhere. That's what it says. Yeah. And then you load the profile, which is the number of environment variables, and then you can run the program, which is in opt racket bin racket, and it will give you a prompt. I should have given a Guile example, but anyway. So Geeks is written in Guile, so we need to install that first. And I'm also installing some nice packages that go with it: Emacs Geyser, and paredit. And when you do that, you can do something like this. I haven't prepared as well. There we go. You can start the REPL, with the meta command x shell and then run Geeks REPL. So Geeks REPL is really just a command line tool. Geeks, and it drops you straight into a Lisp REPL. and it allows you to interact with Geeks. Yeah, so the Geeks package manager. And here, for example, we say, okay, use these modules, use Geeks, use GNU packages scheme, and then tell me about the Racket package. And it gives you information on the Racket package, including which file it sits in, GNU packages scheme, and the line number. Yeah, so you get this facility where you can actually interact with the Geeks package manager through Lisp. And you can query data. You can say something like package version Racket. Yeah, so let me try that. It's always dangerous to try things on the command line. Ooh. Come on. What did I say? Racket? Yeah, so here's the package thingy. And then I need to say, for example, package version Racket. Version. And returns you the version that's installed. Yeah, so, and there's a lot more to that. So you can get all the information that's in the package manager. And if I show you what the package manager looks like, that's the wrong one. Jeez. Too many things are open now. My poor small brain. So if you have, for example, here's the package definition in Geeks. Yeah, you could say define public, which is and then the package name, which is called Ruby connection pool. And this is a Ruby gem. You know, it's a Ruby package that comes with Ruby. And it essentially say, you know, this is the name, this is the version, this is where we fetch it from. It comes from through Ruby gems, right? So it's a Ruby gems URI. And you can see that the Ruby gems, if it was fetched it from Git, it would show the a Git URI. So we have a high-level abstraction here for Ruby gems. The SHA value just says this is what the tarball, what the SHA value should be like, so you don't accidentally get another one. And then the build system is the Ruby build system. Then it has a native input, so that's a dependency. It depends on bundler. And then you have the synopsis and the description. So this all describes one package in Geeks, which is concise, right? And it's also Lisp again. Yeah, so you can understand it now, right? Even if you had this one, this 10-minute introduction on Lisp that I have given. Anyway, so if you query the data that was on the REPL, you can actually get this information that was in the package definition. You can just see it here and do something with it. You can also interact with the daemon. I'm not going to run it now because I don't have that much time. But essentially, you can open a connection with the daemon, which we call S here as a convention, or store, or Geeks daemon. So there's not much of a convention. And then you can then you get what we call a package derivation of the package that you want to build, in this case, or install. This is Ruby. And a derivation is sort of the lowest data representation of a package. Yeah, so it includes all the dependencies and everything. And then you simply say something like derivation, that's what it returns. This is how you fetch the file name of the derivation. And in this case, we want to build it. So we say build derivations, with the daemon, and then take a list of the derivations. In this case, it's a Ruby derivation, which was fetched here. Yeah, so if I run that, it should install Ruby, which is always a bit dangerous. So let me try and cut and paste that. Live dangerously when you give a demo. Yeah, so it returns true, but because the package is already installed. Yeah, but so it doesn't reinstall, unfortunately. Very convenient for demo. But yeah, but that's it. That's all there is to it. How many? 9. Okay, that's cool. And then we have a concept called the store monad. So when people talk about monads, they usually think about things like Haskell, functional programming languages. You can also do this in Lisp. 5. Oh, thanks. Yeah, so, and the specific monadic functions which avoid you to reference the daemon or the store or the connection every time. So, rather than the earlier, here we explicitly had to set build derivations S and then something. Yeah, so here we can just say package derivation Ruby, and you don't have to relate to the. I mean, the monad carries the definition of the store with it, so you don't have to reference to it again. And this is another way of simplifying the code, because otherwise you would have many references to the daemon, and that's actually not necessary. So to capture it all, with Geeks, the source code is the documentation, I think. And we show some high-level functionality for building and exploring packages. And the fun thing is you can also use a debugger, so you can actually step to, when you build something, you can step through the code that is the package definition and what it does with it. And it's all the unified Lisp syntax. So your distro here is a scheme library for hacking, through the GNU Geeks APIs. And here's some links which are available. I'm going to skip this one. So just like Emacs, Geeks is for programmers. Yeah, so once you master Lisp, you can do anything really. So I'm going to quickly touch on another Lisp which has become very important in the business environment. Is Clojure. And it's a little bit. I mean, the Lisp people in general, when they frown when you mention Clojure, because it's a little bit different from most Lisps. But I think it's not. I can't say superficial, but it has very interesting ideas. So it's a different. Conceptually, it's a different beast altogether. But it shares things with the other Lisps, including the syntax. It takes a little bit of some freedom when it comes to saying, okay, rather than writing. Where did that go? I think something disappeared. Oh no, that's probably the same. So that's a list, right? But this is a vector, right? And a vector in the other Lisps, or at least in Scheme, would be written like this. And this is a hash value or a dictionary, and this is what it looks like in the other schemes. So there's some differences, and I think it was this is meant to make it nicer for people who are coming from JavaScript, Python, Ruby, and all that. But it's the same thing. In fact, underneath it will return similar values. And then Clojure has a lot of ideas around functional programming, including immutability and shared state handling, which are all important. And it compiles to the JVM, which is an advantage if you like it, and it's a disadvantage if you don't like that. And Clojure scripts, which is also Clojure, translates to JavaScript. So essentially you have one language that can target either the JVM or JavaScript, and I think in a business environment that can be pretty attractive. But that's not to say that this is the only way to do things, because there's for example, Biwa Scheme is a JavaScript interpreter that runs in the browser, and when you use that, you can do something very simple like this, which is HTML, and then you script the Biwa Scheme JavaScript interpreter, you pull it in, and then you can just write Scheme again. And I think this is actually a very interesting tool. WeScheme is a Racket IDE that runs in the browser, so that's another browser interpreter. ParentScript takes a slightly different approach. It's a JavaScript generator, so it's more like Clojure script. And Spock is the chicken scheme to JavaScript generator. So these are all projects that can do pretty complicated things. And it all originates on the fact that writing a Lisp interpreter is not that hard. A lot of people even learn that in school, in university, at least maybe not the last 10 years, but who has learned to write a scheme or a Lisp interpreter in school? See? Yeah, that's a few. So it shows you it's possible, right? I mean, if anyone written a C++ interpreter here? They also exist, you know, but they're very crazy beasts. So Spock can compile to either C or JavaScript, you know, and it's a chicken scheme. And I'm going to wrap up now because the take-home message, I think, is that Lisp is one or maybe many languages that serve all. I think that's the key thing. And you know, there are many great Lisps. Lisp is easy to learn. Lisp is everywhere. It can be used anywhere. It's for newbies and gurus alike, in my opinion. You know, I'm probably still a newbie. But what is really important in this age of millennial angst is that you know, you don't have to worry about what language you have to learn after this, right? It's not. There's so many people that come to me and say, you know, should I learn Rust? Should I learn Python? Should I learn R or whatever? You know, and I'm just say, well, you know, that's fine. You should you should learn them all. But once you reach to the stage that you have learned Lisp, you probably, you know, you're over it. Thank you. Any questions? Yeah.
I noticed that at the Geeks repo, there was a lot of answers, $sign number. Does it mean it saves all the answers?
Yeah. 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 So the Gal REPL saves all the answers. That's true.